centrifugal force of revolution. So, it said, a propitious morning to everyone present here. I, Adyasha Vijita, going to present my topic, superlubricity, the sliding regime. Friction is a force that resists the initiation of sliding motion between two surfaces. It is all around us and occurs at all surfaces. Over 500 years ago, Leonardo da Vinci was the first person to study friction systematically, and his main results are still used by many engineers today. In 1699, Amundsen published his rediscovery of the laws of friction, first put forwarded by da Vinci. Now, let's understand friction in a finer manner. Question. A car of mass 1.2 tons is traveling along a straight vertical horizontal road at a speed of 20 meters per second. When it brakes sharply, then skids. Friction brings the car to rest. If the coefficient of friction between the tires and the road is 0.8, then calculate the deceleration and the distance traveled by the car before it comes to rest. Let's think about what is the value of friction while the car is skidding. As the vertical forces are in equilibrium, so R is equal to 1200 kg. As we know, 1 ton is equal to 1000 kg. Putting the formula F is equal to mu R, we get friction is equal to 9408 Newton. And by putting Newton's second law, F is equal to ma, we get friction is equal to minus 7.84 meter per second square. Now the deceleration is known. Which of the equations of motions can be used to find the distance? Using v square minus u square is equal to 2as, where u is equal to 20 meter per second and v is equal to 0 meter per second and a is equal to minus 7.84 meter per second square, we find distance s, that is 25.5 meter. With the ongoing world topic of global preservation, is there any way that this force is contributing to its worsening rather than betterment? Worldwide, about 100 million terajoule is used annually to overcome friction, and that is 1/5 of aggregate energy produced. Based on recent studies, researchers have concluded that it is possible to save as much as 17.5% of energy use in a short term of 5 to 9 years by effective execution of new tribiological solutions. Scientists have long worked on the origin of friction and are engaged to achieve an absolute friction-free state, and rapid progress has been made now. Liquids were first used as lubricants to turn down friction. However, their performance is seriously affected in severe working environments. Thus, solid lubricants have been considered as they are exemplary. So, the friction mechanisms can be divided into interlayered and surface sliding friction mechanisms. In 1928, Bragg attributed the low friction behavior of flake-like materials, while Hirano studied two clean, clear crystal surfaces and found special cases in which friction completely disappears. So that is a very special case in which friction almost disappears between two crystalline surfaces in a dry, rigid, and clean incommensurate contact. So let's move on to commensurate and incommensurate. Commensurability is due to leading to high alignment of friction, which lead to high friction state, whereas incommensurability due to twisting, that is misalignment of the box, leading to ultra low friction. By this, superlubricity was confirmed. This effect was dubbed as superlubricity in 1991. But more recently have technological developments in microscale fabrication advanced to the point where it can be seen. It is appraised that the future applications of superlubricity could result in an annual economic benefit of worth trillions of US dollars. So, shall we know that's how this can be relevant for our reality? Using nanostructured materials as substrates for the production of new biomedical sensors useful as medical diagnosis systems, at Rochester, recently researchers discovered a novel silicon membrane. Currently, nanotechnology plays a vital role in water purification, which is useful for the purpose of softening the water and removal of physical, biological, and chemical contaminants. It has witnessed a successful usage in aircraft construction as filler materials, improved electronics, and displays with low power consumption. A knowledgeable fact is that NASA's morphing program makes extensive use of nanotechnology, for instance, by developing electroactive polymers to improve sensing and actuation. Nanoscale models are being developed to prolong the lifespan of wind turbines and lower the overall cost of energy generation. So, it is very rightly said, genius is 1% inspiration, 99% perspiration. This invention can lead us down a path of fact-finding that is aimed at eliminating friction and focused on experimental aspects of superlubricity that will be very widely used for international community. I would end my presentation saying that the process of scientific discovery is in a continual flight from wonder. Thank you.
Thank you, Adyasha. That was a presentation worth remembering. Now I request the judges to ask their questions.
There's a nice presentation. You presented well, but I could see in your PPT you have mentioned a thing which is represented as AFM. Can you tell me what is the full form of that AFM?
Yes, sir. AFM means atomic force microscope.
Okay, good. Now, if I place
sir, in superlubricity it poses a challenge due to which deep sample interfaces by friction. So superlubricity is a promising way in which we can clear out this problem.
Okay. Now, if I place a book on the table, friction is there.
Yes, sir.
Can you tell me which type of friction is that?
Sir, when a book is placed statically on a...
I'm just simply placing a book on the table. That's it.
Yes, sir.
Which type of friction is there? Okay, take it. Ma'am, if you want,
static friction.
Static friction.
Yes, sir.
Okay.
Okay, Adyasha, very nice presentation.
Thank you, ma'am.
You have presented well also.
Thank you.
What is the difference between superlubricity and lubricity?
Yes, ma'am. Ma'am, in lubrication, ma'am, mostly as I said, ma'am, as before I said that liquid lubricants were used, and now due to superlubricity, only solid lubricants are being used. As liquid lubricants cannot be used anymore, so solid lubricants in superlubricity, only solid lubricants can be used to reduce friction or vanish friction.
So what are the advantages of superlubricity? Advantages?
Yes, ma'am. It is a new invention recently going on, and as I had said that recently, and in roster also for biomedical sensors, it is being used. In upcoming years, it will be used broadly for the international community. It will be more useful, and the advantage is that it is economic saving, and there will be no economic depletion due to this, and there will be no environmental issues.
Now, can you give some examples?
Ma'am, of example of?
This superlubricant.
Yes, ma'am. Ma'am, as I said, when we take egg shell, which we have, eggshell, when we arrange two eggshells with alignment, it is called as commensurable. But when misalignment is there, it is incommensurable. This is an experiment which is proving superlubricity.
Okay, thank you.
Thank you, ma'am.
Thank you to Adyasha. So our next participant is Prajakta Nanda of Standard 11A. Prajakta, kindly respond.
Yes. Hello. Am I audible?
Yes, you're audible. Yes, you're audible.
Prajakta, make it slideshow.
Yes, sir. Good morning to one and all present over here, respected judges, teachers, and my dear friends. I'm Prajakta Nanda of class 11A, going to present on the topic normal forces. Normal force is a force which always acts perpendicular to the surface of the contact. When an object is placed on a horizontal surface, for example, table, the object exerts a force on the table due to its weight. According to Newton's third law of motion, the table also exerts an equal and opposite force on the object, which is termed as normal force. When no external force is acting on the object, the normal force is equal to the weight of the object, that is F is equal to mg. Considering the situation when external forces do act on the object, suppose we push an object at an angle theta, the resulting normal force is greater than that of the weight of the object. Suppose we pull an object at an angle theta, the resulting normal force is less than that of the weight of the object. Considering another case, when an object is placed on an inclined plane, the horizontal component of the weight of the object, that is mg cos theta, is acting opposite to that of the normal force. So in this case, the normal force is less than that of the object's weight. Considering another case, when a person is standing on a scale in an elevator, three cases arise. Firstly, when the elevator is moving upward with an acceleration a, the normal force is equal to the weight of the person, that is mg, plus the force due to acceleration, that is ma. So here, the normal force is greater than that of the weight of the object, and hence the person tends to feel heavier. Secondly, when the elevator is moving downward with an acceleration a, here the normal force is less than the person's weight. So here the person tends to feel lighter. In case a situation arises and the cable breaks, the elevator starts to fall freely under gravity. So here the acceleration is equal to gravity, and here the normal force is 0. So the person tends to feel weightless, which is termed as apparent weightlessness. To understand the concept better, let's consider an example. A toboggan is loaded with students, total weight W, slides down a snow-covered hill. The hill slopes at a constant angle alpha. The toboggan is so well waxed, there is virtually no friction. Find the magnitude of normal force exerted by the hill on the toboggan. So here in the left diagram, we can see the students on the toboggan sliding down a hill slope, making an angle alpha with the horizontal. Moving on to the free body diagram, we can see there are two forces that are present, that is the normal force and the weight of the toboggan. According to Newton's second law of motion, the x component of the net force is given by W sine alpha, which can be also written as max. The y component of the net force is given by n minus W cos theta, which can be also written as may. But we also know that the vertical component of the acceleration is 0. So we can write n minus W cos alpha is equal to 0, which implies n is equal to W cos alpha, which can be also written as n is equal to mg cos alpha. So in this problem, the normal force is less than that of the toboggan's weight. So I arrive at my conclusion of my discussion, that normal force is an everyday force. It can be felt and seen everywhere. It is a reaction force. It is always acts opposite to the component of the body's weight, that is perpendicular to the surface. Thank you.
Thank you, Prajakta. That was a wonderful presentation. Now I request the judges to ask their questions.
Nice, Prajakta. You presented well. Can you tell me the existence of action-reaction pair in Newton's third law? Can you tell me about it?
Sir, suppose as an example, when we walk on the ground, sir, our foot applies a force on the ground, which can be termed as action, and the ground also exerts an equal force on our foot, which is the reaction, and for that reason we are able to walk. Apart from friction, that is the reason we are able to walk on the ground.
So who comes first, action or reaction?
So action.
Action comes first.
Yes, sir.
And then we see the reaction.
Yes, sir.
Okay, ma'am, please.
Okay, Prajakta, can you tell what the sir told and the example you told, that when you are standing on the floor, floor is giving you certain force. So which one is action and which one is reaction?
Ma'am, the force given by our foot is the action, and the force given by the floor is the reaction.
Can it be force given by the floor is action and you are giving it the force that is the reaction? Can it be?
Ma'am, I think we need to put a force first.
First, who is giving the force? When you are pushing the wall is giving you a force. You
Yes.
are giving a force to the wall is also giving a force to you. Then
Yes.
which is action, which is reaction?
Ma'am, we are giving the force to the wall, like pushing the wall, so it can be considered action, and the wall giving us an equal force is the reaction.
So can the reverse be true?
No, ma'am, because there is no contact between us and the wall. So, how can the
No contact. There is no contact.
no, ma'am? If we are first, we have to apply a force first from our side to feel for the force wall.
Mhm. Okay, both can be done. Both can be action, both can be reaction. Okay,
Yes, ma'am.
thank you.
Thank you.
Thank you, Prajakta. So our next participant is Rishita Das of Standard 11B. Rishita, kindly respond.
Yes, just a second.
Yes, you can start your presentation now.
Here it's showing that host disabled participant screen sharing.
Minute, Risita, wait. You have joined by which one? Risita Das, no?
Yes, sir, I've joined by 2 devices.
Okay, 11. Okay. 2 devices, which will be, one is being made co-host, no? Okay. Is it been now there? Fine?
Yes, sir.
Yes, it is visible. You can start. Okay.
Good morning, one and all present over here. Myself, Rishita Das of 11B. I am going to present on my chosen topic, friction. How do things move in real life? Say a ball is moving on a flat ground and there is no external force acting on it, but it eventually comes into rest. Say my friend is skating on a road and I am skating on ice rink. So whose movement is going to be smoother? Definitely mine. What's the reason behind all my questions? The answer to all my questions is friction. Friction, the reason why the ball comes to a halt is friction. The reason why ice skating is smoother than the road skating is the lesser friction present in the ice rink. Friction is nothing but a force which acts opposite to the relative motion between the two bodies. It comes into play when two bodies are in contact and try to overcome the irregularities they are interlocked in on their surfaces in microscopic level. Friction mainly depends on many factors, but the main factors are firstly, molecular adhesion. Molecular adhesion means the molecules of both the bodies in contact try to attract each other at each point of contact, making it difficult to slide on each of them easily. The second reason is roughness. It's obviously easier to slide on a smooth surface rather than a rough one. And thirdly, deformation. Generally, soft bodies undergo deformation under high pressure. This also increases resistance to motion. We often think that friction is dependent on area of contact, but it's just a misconception. Friction is never dependent on area of contact. Interesting fact about friction is friction also acts as a pair. that is reaction and action. In the diagram I have shown in the PPT, block A is placed on block B, where block A is for an external force is applied on block B towards the east direction. So the resultant is the friction on B due to A, which acts towards the east, and the friction on A due to B acts towards the west. This shows the action and reaction force. Mainly, there are two kinds of friction. Firstly, static friction. Secondly, kinetic friction. Static friction is a type of friction which comes into play when there is tendency of relative motion. It opposes the impending motion, which would have happened if there would be only the external force in play instead of the friction. Kinetic friction is a friction which comes into play when there is real actual relative motion. So let us now see what static friction is. As we all know, static friction is a friction which comes into play when there is tendency of relative motion. It's kind of a variable friction, means self-adjusting friction. It adjusts itself in all kind of circumstances. So the value of static friction varies from 0 to the limiting friction. Static friction is denoted by Fs. Now our question arises, what is limiting friction? Limiting friction is the maximum static friction between two bodies, between two static surfaces. For as limiting friction is a constant, so it has a formula which is limiting friction equal to mu s into n, where mu s is the coefficient of static friction, which is a constant, and n is the normal reaction. Fs or static friction has no formula because it is variable in nature. The point to be noted is body moves only if the force we apply exceeds the maximum static friction or limiting friction. Let us solve a numerical on static friction to know more about it. In the question, it is given a box of mass 4 kg with, on which an external force of 6 Newton is applied, with coefficient of static friction given as 0.2. And the question is to find friction. So we know the formula for limiting friction, which is equal to mu s into n. That is equal to mu s given in the question as 0.2 into normal reaction, which in this question is same as that of the gravity, which is mg. So 0.2 into 4 into 10, that is equal to 8 Newton. So the force applied, but in the question, the external force or the force applied by us is 6 Newton. In this case, force applied is less than the limiting friction. So the limiting friction adjusts itself as force applied, because in physical world, it is not possible that we apply force in one direction and the body moves in the other. So here, the limiting friction adjusts itself to the applied friction, and the final friction is 6 Newton. So this shows that the body is in rest. Let us learn about kinetic friction. Kinetic friction is a constant friction, means it does not depend on the speed of relative motion. So it is denoted by Fk. So Fk is directly proportional to n. In order to change the directly proportional sign to an equal to sign, we need a constant of proportionality. So Fk equal to mu k into n, where mu k is the constant of proportionality and popularly known as coefficient of kinetic friction. Mu k depends on surfaces in contact. Its value is found experimentally. Kinetic friction does not depend on any other thing. Its direction is, it just opposes this relative motion. Let us solve a numerical based on kinetic friction to know more about it. In this numerical, we are firstly asked to find the normal reaction, secondly the kinetic friction, and finally the acceleration. In the question, a block is given of mass 4 kg with an external force of 10 root 2 Newton, which is at an angle 45 degrees with the horizontal. I took this question as an example in order to clear the misconception which most of the students have in mind, that normal reaction is always same as the gravity or mg. But in this question, It's not so. Firstly, we are required to find normal reaction. So the total force in the upward direction is the vertical component of the force applied and the normal reaction, which is n plus 10. And the total force in the downward
Rishita,
direction,
quick up. Already you have exceeded 2 minutes. Okay. Be
sir,
quick.
yes,
Okay.
which is n plus 10 equal to 40. That implies the normal reaction we got is 30 Newton. We equated n plus 10 equal to 4g because there is no movement of the block in the vertical direction, means the forces in the upward and downward directions are balanced. Secondly, we are required to find the kinetic friction. So kinetic friction equal to mu k into n. So Fk equal to 0.3, which is mu k, into 30, which is the normal reaction we got in the previous question. That is equal to 9 Newton. Finally, we are required to find the acceleration. So the acceleration is means the total force is in the east direction is 10 Newton, which is the horizontal component of the force, and the total force in the west direction is the frictional force in the west direction. So 10 minus 9 equal to ma. So the resultant force is 1, that is equal to 4a vector. That implies a vector equal to 0.25 meter per second square. Applications of friction in everyday life. Friction helps us in walking, in pushing a box, or in winter season, we rub our hands to get warm. So friction is necessary for us. But in some cases or in machinery, friction causes wear and tear and also converts sometimes into heat energy, which is a waste. This is an evil face of the friction. So friction is often regarded as a necessary evil. Thank you.
Thank you, Rishita. That was quite a presentation. Now I request the judges to ask their questions.
Okay. So Rishita, it was a nice way. I'd just ask you a simple question that you told about two types of friction, limiting friction and kinetic friction. Can you tell me an example where your limiting friction will be greater than your kinetic friction? Can you give me a suggestion, situation where you find that limiting friction is greater than?
Sir, no, sir, limiting friction can never be greater than kinetic friction.
Can never be greater than kinetic friction.
Yes.
Okay, fine. Ma'am, over to you.
Okay, Rishita. Why you are not smiling? Smiling face should be there when you are presenting, isn't it? So you are looking stressed. So don't be stressed. One question to you. Do you know that have you seen the wheel is rolling on a road?
Ma'am, I'm unable to hear you actually.
Wheel is rolling on a road. Have you ever seen?
Yes,
Road.
wheel.
Wheel. When wheel is rolling on a road, in which direction the friction acts?
Ma'am, if the wheel is running on a road towards the east, then the friction also acts towards the east.
Can you explain how?
Ma'am, because if the wheel is running towards the east, then the acceleration on that means it is applying force in the backward direction in order to roll. So the friction is finally towards the acceleration of the wheel itself.
Okay, good. Thank you.
Thank you, ma'am.
Thank you, Rishita. I would like to remind the participants again that the bell will exactly ring at 5 minutes and you have to wind up your presentation within that. So our next participant is Ayushman Panda of Standard 12B. Ayushman, kindly respond.
Good afternoon, ma'am. Good afternoon, sir. Just a second, share.
Ayushman, you share?
Yes, sir, share. Sir, is the PPT visible?
Yes.
Good morning, one and all
You
present
switch
over
on your
here.
video. Okay.
Good morning, one and all present over here. This is
Switch on your
Aishman
video.
Pandit. Sir, my video is on.
Okay. Okay.
Good morning, one and all present over here. This is Aishman Panda from class 12B, going to present on the topic gravitational force, the nature's ultimate goal. First of all, let's know what is gravitation. Gravitation is just gravity, is a force of attraction between any two bodies, starting from a tiny piece of paper placed on your table to the planets in a solar system. Each object exerts a force of gravity on another. Let's look at some basic examples to know more about it. If a ball is thrown upward, it reaches a certain height and falls downward because of gravity of Earth. There is a constant downward acceleration of 10 meter per second square or 9.8 meter per second square that tracks the ball down. Secondly, the planets revolving in our solar system. We know that planets revolve in certain elliptical imaginary paths that we call as orbits. These orbits exist because of the gravitational force that the sun exerts on the planets and the planets exerts upon themselves and the sun. Now, a great question arises. How was this great theory of gravity first discovered? This amazing theory of gravity was first proposed by many great scientists, such as Ptolemy, Nicolaus Copernicus, as well as Kepler. But this great theory of gravity was given by Sir Isaac Newton. Once, when he was sitting under a shade of an apple tree in the countryside, wondering about the marvelous forces of nature, suddenly an apple fell from a tree above, which got him into thinking. There must be some kind of force acting on the falling objects like apples, otherwise they would not start moving from rest. He named this force as gravity and determined that gravitational force exists between all the objects. These are some of the applications of the gravitational law given by Newton. The moon revolving around the earth, the tides caused in the sea due to the gravitational force of the moon. Now, Newton also gave an equation for the Newton's gravitational law. According to Newton, every particle in the universe attracts every other particle with a force whose magnitude is directly proportional to the product of their masses as well as inversely proportional to the square of the distance between their centers. If we put these two equations in mathematical form, we find F is directly proportional to m1 m2 by r square, where m1 and m2 are the masses of the object. Now, to remove the proportional sign and put the equal to sign, we have to insert a constant that we call here as she, that is the gravitational constant, which has a fixed value of 6.674 into 10 to the power minus 11. What Newton gave was an overview of formula, but it's not the end. From this particular formula, many formulas were derived that are used today in numericals as well as in research field. These are some of the main formulas among them. Now, we read so many formulas, we read about the law, but how to know how they're applied without a numerical question? So in this question, we have a gravitational field intensity at a point 10,000 kilometers from the center of the earth is 4.8 Newton per kg. We need to find the gravitational potential. So before solving any question, we must write what all is given to us. So here we have two values given, the gravitational field intensity as well as the R. So if we directly put the formulas we read above and find the equation of V equal to minus ER, here only one value is unknown and the other two are given. So if we directly put the values in it, we find the value of V as into 10 to the power 7 joule per kg. Now let's move on to another question. In this question, we have to find three values: the force of attraction, acceleration produced in the body, as well as acceleration produced in the earth. What all is given to us in this question? The mass of the earth, the radius of the earth, weight of the body, as well as the gravitational constant that we all know. Now, we know the force of the mutual force given by Newton, F equal to G m1 m2 by r square. If we directly put in the values, we find the answer as 245.36 Newton. Now let's come to acceleration. Long back we had read a formula F equal to ma. That can be also written as A equal to F by m. That can give rise to the acceleration of the body and the earth. But a main mistake that can be done here is the mass of both are different. In the body case, we have to write the mass of the bodies, that is 25, and in earth, the mass of the earth given, that is 6 into 10 to the power 24, and respectively find the is pouring tea in a cup. Secondly, gravity also plays an important and vital role in our solar system by keeping planets and other celestial on their respective orbits that we had already read before. Thirdly, the application of black hole. Black hole is nothing but a place where the gravitational constant is so high, the gravitational force is so high that even light can't get out of the black hole, for which a black hole isn't even visible. Walking is something that we do in our everyday life most frequently. But while walking, we use friction. And for using friction, we need to make contact with the ground. But without the gravitational force, how can we make contact with the ground? So gravitational force has a very vital role in walking and rolling objects. We could not touch the ground or the surface to gain friction without gravity. So lastly, gravity propels object to fall down on the surface of Earth. Anything you throw up comes down eventually, may it be a ball or a fruit. So at last, I would like to conclude that gravitation has many uses, many formulas. This amazing theory was given by Sir Isaac Newton by his amazing brain. Till now, today, these formulas and these theory are used by scientists in many research fields. So I would like to end my presentation here. Thank you all for your patience here.
Thank you, Ayushman. That was quite a creative presentation. Now I request the judges to ask their questions.
S1 very well presented. You tried to correlate between your gravitational force, friction. So nice of that.
Thank
I
you,
would
sir.
just ask you that the planet around the sun, they are being controlled by Kepler's law. Do you know that?
Sir, I could not hear you.
The planet which are revolving around the sun, they obey Kepler's law. Correct?
Yes, sir. Kepler's law of planetary motion.
Right. So can you just tell me first Kepler's law?
Sir, there are three laws of Kepler's. The orbit of a planet is an ellipse with the sun at one point of the two foci. The line segment joining a planet and the sun sweeps out equal area during equal intervals of time. And the third is the squares of planets' orbital period is proportional to the cube of length and semi-measural axis of the. I may
Yes.
not be exact at it, but that's what I.
Fine, fine. You have approached correct. Good. Ma'am, please.
Ayushman presented good.
Thank you, ma'am.
So, can you tell me this gravitational force, is it a conservative force or non-conservative force?
Ma'am, gravitational force is conservative or non-conservative?
Yes.
Ma'am, according to me, gravitational force. I mean, it's conservative force.
Why conservative?
Ma'am, because a work done by force, ma'am, a conservative force exists when work done by a force of an object is independent of the object's path. Ma'am, so gravitation doesn't depend on the path or via which route you are traveling. Gravitational force acts on every field, like maybe in the solar system, maybe on Earth.
So you told according to me, that means according to all others it is different.
No, ma'am, means it is a conservative force. I was just explaining in my language.
Okay, fine, good. Thank you.
Thank you, Ayushman. So our next participant is Smruti Shikha Tripathi of Standard 11B. Smruti Shikha, kindly respond.
Yes. Am I audible?
Yes, you're audible. You can start your presentation.
Yes, just a second. Am I visible? Hello?
Your PPT is not visible?
Sir, am I visible?
Yes.
Yes, sir. I am sharing the screen.
Okay.
Good afternoon to one and all present here, honorable judges, respected teachers, and my dear friends. This is Smruti Shikha Tripathi from 11B. Today for me, it's a golden opportunity to present on the topic frictional force. Now, before going to the detail of frictional force, let us know what is exactly friction. What causes the rolling of this ball on this ground, or how we are able to walk on ground, or what causes the motion of a car on a road. This all happens due to frictional force. Friction is necessary for doing all the actions on this Mother Earth. Hence, it is very important to learn about frictional force in detail. Frictional force is defined as an opposing force developed between two surfaces which are in contact with each other so as to resist their relative motion. It always acts tangentially to the surfaces in contact and in a direction opposite to the direction of motion of the body. Now focus on this diagram. Suppose we apply a gentle push on this block. Now suppose the block does not move at all. What resists the motion of this block? Obviously, opposing or resisting force must be acting. In this case, the opposing or resisting force acting in the opposite direction is called as frictional force. Now, if the pushing force is smaller than frictional force, then the body is at rest. As in this case also, the body is at rest. Hence, we can say that the pushing force must be smaller than the frictional force. Now, if the pushing force is nearly equal to frictional force, then the body tends to move or it just starts its motion. Now let us imagine if we give a gentle push to this block and this block just starts its motion, then what is the relation between pushing force and frictional force? In this case, the pushing force must be nearly equal to frictional force. Now all of you must be wondering, how this block completely moves on this frictional force. If now in this case, if the pushing force is greater than frictional force, then the body is in motion. Now let us go for the origin of frictional force. Friction is caused due to the interlocking of the irregularities on the two surfaces in contact. Now, as you can see from this diagram, a body is moving on a horizontal surface. These are the irregularities of the body and the horizontal surface respectively. If these irregularities get interlocked among each other, then this causes frictional force. Hence, friction is caused due to the interlocking of the irregularities on the two surfaces in contact. Now let us categorize friction into its three main types: static friction, limiting friction, and kinetic friction. Now let's first deal with static friction. Now what you can observe, this boy is pushing a sofa, but the sofa does not move at all. Obviously there is friction involved in this case, but which type of friction? This is static friction. From the word we can derive static means something at rest. So as in this case, one of the surfaces, that is the sofa, is in rest. Hence, the friction involved here can be said as static friction. The frictional force which acts between two surfaces which are not moving relative to each other or are stationary is called as static friction. Suppose there is a block lying on a horizontal table. We are giving gentle push to this block. Obviously, the static friction will act in this direction. Normal force will act in the upward direction and the weight of the block will act in the downward direction. Now, in this case, the static friction is directly proportional to normal force. By removing the proportional sign, we can say that Fs is equal to mu s Fn. Or as in this case, the normal force balances the weight of the object. We can also say that Fs is equal to mu into mg, where Fs is the static friction, mu s is the coefficient of static friction, which is used as a proportionality constant, and mg is the normal force. Now, let us deal with limiting friction. In this diagram, a man is giving a gentle push to this straw roll, but the straw roll just tends to move. Now, why this happens? This happens because in this case, the frictional force must be nearly equal to the applied force of the man, or we can say that it is equal to the applied force. Now, limiting friction is defined as the maximum static friction which acts between two surfaces when one body tends to move over the other surface. Now focus on this diagram. There is a block lying on a horizontal surface. We are applying a force to the block in this direction. Now let us imagine that the block moves or it just starts its motion. Obviously, in this case, what is the relation between frictional force and applied force? Obviously, F will be equal to Fa. Hence, we can say that the frictional force that is to be overcome before the block completely moves is called as limiting friction. Now, what you can observe in this diagram? In this diagram, two two boys are riding bicycles. Now these two bicycles are in motion. Now what causes the motion? Obviously some friction is involved in this case, as the two bicycles are in motion. Hence from the word we can derive what is meant by kinetic. Kinetic means something is in motion. So as the two bicycles are in motion, the frictional force involved here can be said as kinetic friction. The frictional force which acts between two surfaces which are moving relative to each other is called as kinetic friction. Now, suppose there is a block lying on this horizontal surface. Suppose we are giving gentle push and the block moves in this direction. Now, opposite to that direction of motion, the kinetic friction will act in this direction. Normal force will act in upward direction and weight will act in downward direction respectively. Now, in this case, Fk is directly proportional to Fn. Or we can say by removing proportional sign, Fk is equal to mu k Fn. Or we can also say Fk is equal to mu k mg, where Fk is the kinetic friction, mu k is the coefficient of kinetic friction, and mg is the normal force. Now let us do a numerical based on our information. If a block of mass 5 kg is placed on a horizontal surface and the coefficient of static friction is 0.4 and a force of friction of 3.5 Newton is applied on the block, then what will be the force of friction between the block and the horizontal surface? Now what is given in the question? Mass of the block is 5 kg, mu s is 0.4, applied force is 3.5 Newton and g is 9.8 meter per second square. Now in this case, Fs max is equal to mu into mg, or Fs max is equal to 0.4 into 5 into 9.8, that equals to Fs max is equal to 19.6 Newton. But in this case, the applied force, that is 3.5 Newton, is less than Fs max, that is, or we can say the maximum value of static friction, that is 19.6 Newton. Hence, the body will not move in this case. So the friction between the block and the horizontal surface is equal to applied force, that equal to 3.5 Newton. Now, science is incomplete without its application in its everyday life. So the two applications of frictional force that I have chosen in everyday life are rubbing our hands together to create warmth in winter season. In this case, the frictional force is produced in between our palms in the form of heat or warmth. And the second application is tire traction, that is the frictional force between the tires and the surface of the road that allow our car to accelerate, slow down, and negotiate turns and corners. Finally, I have come to the end of my presentation. Thank you for being a patient listener.
Thank you, Shruti Shikha, for your wonderful presentation. Now I request the judges to ask their questions.
Shruti, very nicely presented.
Thank you, sir.
I would just like to ask you one thing. You have shown normal force is balancing the weight. Is there any situation where the normal force can also balance one of the components of the weight?
Yes, sir. In case of inclined plane, we can say.
Okay, good. Ma'am, please.
Smriti,
Yes,
your
ma'am.
video is not on.
Yes, ma'am. You are not audible.
Your video is not on. We cannot find you. We cannot see you.
Ma'am, I have kept it on.
You can
Just a second.
now make your PowerPoint off and you switch on the camera, then you will be video.
Yes,
Okay.
sir. Yes, sir.
Make your PowerPoint on. Other device you are joining, you join from other device. You have made the video to be off. That is why it is not coming. You start video, in that case, start video, you can click. Start video in the below
Yes,
button.
ma'am. Am I visible now?
Yes.
Okay. Yes, now you are visible. Okay. You have explained so nicely. Can you tell me what is the relation between angular friction and coefficient of friction?
Angular friction and coefficient of friction.
Yes. Is there any relation between them?
No, ma'am. I have no idea about it actually. I will read about it.
Okay. Coefficient of friction you have mentioned. What is that coefficient of friction?
Ma'am, it is the proportionality constant. Means we can say that the friction is directly proportional to the normal force. Hence, by removing the proportional sign, we use means proportionality constant in that case.
So in that case, F means the frictional force will be equal to mu into normal force, where mu, that is the coefficient of friction, is used as a proportionality constant.
So mu is equal to how much? Mu is equal to what?
Coefficient of friction.
That is equal to, tell the relation.
Ma'am, mu is equal to frictional force by normal force.
Yes. So what is this unit?
Ma'am, you are not audible to me.
What is this unit?
Ma'am, it does not possess any unit, because both the force and normal force are the forces, so they will possess Newton unit, hence the Newton will be cancelled, hence it will not possess any unit.
Okay, can you tell me why synthetic rubber is preferred in tires? Why synthetic rubber is preferred in tires?
Ma'am, to reduce friction.
Reduce friction?
No, ma'am, to increase friction, so that accidents accidents cannot happen.
Okay, read properly. Thank you.
Yes, ma'am. Thank you, ma'am.
Thank you, Smriti Shikha. So our next participant is Snehanshu Das of Standard 11C. Snehanshu, kindly respond. Smriti Shikha, kindly stop your sharing. Snehanshu, kindly respond. Snehanshu, are you ready with your presentation? Sir, can you kindly make Snehanshu co-host so that he can present his seminar?
Good afternoon, everyone. Am I audible?
Yes, you're audible. You can continue your presentation.
A very good morning to one and all present over here. This is Nyanshu Das of 11C going to present today's seminar on one of the most common forces in mechanics, tension. Now, here in this figure, we see that a body of some mass is hanging off the ceiling with a tight rope. Now, we know that anything under the influence of gravity tends to be accelerated. But why is it not accelerating downwards? Why is it at rest? As it is at rest, there must be some force that's countering the gravitational force, and that is none other than tension. Now, what is tension? The contact force that is transmitted through a cable, rope, or wire when it is pulled tight by forces acting from opposite ends is known as tension. When two bodies are in physical contact, are in indirect contact with the help of a rope or cable, in that case, the tension force comes into play. It is always directed along the length of the cable and it pulls equally on the objects on opposite ends of the wire. Now that we know what is tension, let's look at the origin of tension. In this figure, we can see a ball is hanging off the wall with the help of a rope, and if you magnify this part, we can see small segments, atoms, and molecules of the rope. An important part of tension is tension acts at each and every part of the rope. So when atoms or molecules are pulled apart from each other, they can potential energy, but there's still a restoring force acting on it. This restoring force tends the body to be at equilibrium, and hence it creates tension. We say that string transmits force, but how is it? Each microscopic segment of the string pulls on, as in the figure, and is pulled upon by its neighboring segments with the force equal to tension. And thus, segment by segment, from one point to another point of the rope, that the force gets transmitted. Now, let's look at explanation of tension. Now, here is a man which is pulling the block, and he's pulling the block towards himself, and the tension, according to the third law of motion, it is acting opposite to it, and the tension is transmitted through a rope, which helps the block to move towards the direction of force. And these are some common illustrations of tension. In the first one, there is a force which is acting on a single mass, but as they are connected through rope, all the masses tend to move in the direction of force. And in the second pulley one, as the string is same, the acceleration is same, and acceleration is towards the heavier mass. And the third one is the combination of both the first and second diagram, where the acceleration is downwards. Now let's look at some properties of tension. Tension in the same string is always constant and is always a pulling force. Tension acts at each and every point of the rope. If a cable or rope is massless, then it perfectly transmits the force from one end to another end. As we need net force zero on the rope. So according to the second law of motion, the mass should be zero. Tension is a vector quantity, and there's no exact formula to calculate tension, as calculation of tension depends on the situation and problem given. Like in equilibrium system, it can be is equal to mg, or it can be something else. Evaluation of tension by numerical. So we have been given that two blocks of mass 50 and 30 kg connected by a massless string passes over a light frictionless pulley on two smooth planes inclined at 30° and 60° respectively. We have to calculate the acceleration acting on two blocks and tension in the string. As given in the figure, the angle of inclination 30°, 60°, and it is the same string acting on 50 kg and 30 kg. Now, when we draw the free body diagrams, we can see that the normal force acting on the 50 kg mass, the mg acting on it, and these are the horizontal and vertical components of mg. And same here in the 30 kg mass. And as the masses are connected by a single string, the tension is same, and of course the acceleration is same in both the blocks. Let's consider acceleration to be towards the 50 kg mass. So if we consider acceleration to downwards the 50 kg mass, these are the equations that we get, and when we equate them, we get the acceleration is equal to minus 0.12 meter per second square. Now, this minus 0.12 meters per second square, what does it mean? This means that our first assumption that it moves upward is wrong, and it actually moves is down. It actually moves upward, and the 30 kg block slides down with acceleration 0.12 per second square. And after substituting the value of A, we can easily find tension, that is 256 Newton. Now, applications of tension in everyday life. Pulling a bucket of water from well is one of the most common examples when we are able to pull water from well with the help of tension force and tight rope. The tension force is the primary force in the game of tug of war. Without it, there will be no winner at the game. And crane machine. The crane uses strong cables to lift up heavier masses from one point to another. And the elevators. The entire elevator system is connected with strong cables, and all the movements of elevators are controlled by these cables. With this, I wind up my presentation. Thank you all and have a great day.
Thank you, Snehanshu, for your wonderful presentation. Now I request the judges to ask their questions.
Thank you, Snehanshu. Presented well. Am I audible, Snehanshu?
Yes, ma'am, you are audible.
Okay. So, in that explanation, one slide you have shown that one body this side, another body this side, they are on one inclined plane.
Yes,
right?
ma'am. Yes.
So, there, the frictional force, can you tell me in which case the frictional force is equal to the acceleration, that frictional force will be equal to mass into acceleration? In which case?
Sorry, ma'am, I don't know the answer.
Frictional force is equal to mass into acceleration. Any situation is there. Achha, frictional force is a conservative force or non-conservative force?
Ma'am, it's a conservative force as it depends on the path.
So the force which depends on the path is conservative?
No, ma'am, sorry, ma'am. I'm non-conservative.
Yes, thank you.
Welcome.
Now, sir.
Okay. So fine. You uttered a word called restoring force while swinging.
Yes, sir.
Can you just tell me what is a restoring force?
Sir, restoring force is a force which acts on a body to keep it at equilibrium.
Okay, can you explain that restoring force taking into a simple pendulum which is having a thread and we have a pendulum which is moving? So can you just explain me in that context?
Sir.
I have a simple pendulum. I take it to the extreme end, right?
Yes, sir.
I leave it. So what will happen? It comes back to the equilibrium position, right?
Yes, sir. It comes back.
Then it overshoots to the other side. So where this restoring force during this entire motion, where do you find the restoring force being acted upon for the simple pendulum?
So at two extreme points.
At two extreme points, we have the restoring forces acting on that, trying to bring it back to the equilibrium position. Okay,
yes,
good, good. We shall move to the next one. Fine.
Thank you, sir.
Thank you.
Thank you, Snehanshu. So our next participant is D. Harshita. D. Harshita, kindly respond.
Yes, can I present now?
Yes,
Am
you
I
can.
audible?
Yes, sir. Yes, Artiza.
Yes, sir.
You make your PowerPoint first to be presented.
Am I audible?
Yes.
It's the gravity that shapes the large scale structure of the universe, even though it is the weakest force, quoted by Stephen Hawking. Good afternoon, everyone. I am D. Harshita, present here to discuss my PPT about gravitational force. Gravitational force, also known as gravity, the universal law, it is the universal force of attraction acting between all the matters on the earth. All bodies have a weight or downward force of gravity proportional to their masses, which the earth's mass exerts on them. The gravitational force is a force that attracts any two objects with mass. In fact, every object, including you and me, is pulling on every other object. This is called Newton's universal law of gravitation. Newton's universal law of gravitation states that the force acting in each other is directly proportional to their masses and inversely proportional to the square of the distance between them. As I have presented a picture here where the two masses, mass 1 and mass 2, exert two forces F1, F2, which are equal and which can be found by the formula G into M1, M2 by R square, where R stands the distance between the two masses. Sorry, there's a glitch. Am I audible? Hello? Can anyone correct me if I'm not audible?
Hello?
Yes, you are audible.
Audible, you are audible.
Thank you, thank you. The acceleration of a body in free fall under the influence of Earth's gravity expressed as the rate of increase of velocity per unit time and assigned the standard value of 9.8 meter per second square, also known as G. Since the gravitational force since the gravitational force increases, since the centrifugal force increases and decreases in some places, it affects gravitational force also. Since the gravitational force points towards the outward from the center of rotation, it tends to cancel out a little bit of Earth's gravity. As Earth is not a perfect sphere, it's closer to ellipsoid. In fact, if the Earth were not spinning, then we would feel heavier as we would feel full force of gravity. This affects some of the places like gravity in the gravity is maximum at the poles and minimum at the equator. Gravity is maximum at the surface of the Earth and it's zero at the center of the Earth. And gravity is inversely proportional to height as it is inversely proportional to R square. And gravity is zero, and gravity is also zero at infinity. Now I will talk about the Kepler's law, the three important laws. First law, the law of orbits. All the planets revolve around the sun in elliptical orbit, having the sun at one of the foci. Here you can see in the picture, B and C are the points close to the Earth known as perihelion, and A, the far point known as aphelion. Second law, the sun to the planet sweeps out equal areas in equal intervals of time. This is stated by the law of areas. As given in the picture, the area 1 and area 2, irrespective to where the planet is in the orbit, it sweeps out the same area in the same interval of time. Third law, law of periods. It states that the square of the time period of a planet around the sun is an elliptical orbit, which is directly proportional to the cube of the semi-major axis, or we can say average distance from the sun. Simply, P square is inversely proportional to A cube, where P stands for time period and A stands for average distance from the sun. Since the force required to lift an object, it is equal to its weight, which is multiplied by the distance, the height of the lifted object and the gravitational force. Here, the numerical of using the formula m equals to 4 pi square into r cube by g into t square. Earth satellite. Earth satellite are the normal objects which revolve like Earth revolve and planets revolve around the sun. And some of the examples are International Space Station and Explorer 1, etc. Characteristics. As we know that gravitational force is a conservative force, it is a long-ranged force, and it is attractive force. It has many applications, like starting from writing with a pen and ending where the Earth revolves around the sun. I would conclude my presentation. Thank you for the opportunity.
Thank you, Harshita, for your wonderful presentation. Now I request the judges to ask their questions.
Harshita, you must be knowing a formula. F is equal to G m1 m2 by r square. Correct?
Yes, sir.
G, what is it?
It's a gravitational constant.
It's a dimensionless quantity or a dimensional quantity?
So it's a dimensional quantity.
So how can you just tell me the process? How do you calculate?
So by the formula F equals to, so with the gravitational acceleration due to gravity, with the formula of that, we can find out the amount or the magnitude of the gravitational constant.
So if you consider Earth as a sphere, and I take a body to the center of the Earth.
Yes, sir.
So what will be the weight?
So weight of
that body?
No, so 0.
Why?
So because the gravity at the center is 0.
According to which formula?
So according to the G equals to, so according to the, no sir, I don't remember the formula.
Okay, fine. Ma'am, over to you.
Okay. Harshita, well presented.
Thank you, ma'am.
So you have mentioned gravitational potential energy. Can you tell what is gravitational potential energy? Can you define gravitational potential energy?
No, ma'am. I don't know the definition of gravitational potential energy. I will work on it, ma'am.
Okay. Okay, thank you.
Thank you, ma'am.
Thank you, Harshita. So our next participant is Vidhubhushan Patra of Standard 11E. Vidhubhushan, kindly respond.
Good afternoon, everyone. Am I audible?
Yes, you're audible.
Just a second. Is the screen visible?
Just make it slideshow. Yes.
First of all, esteemed principal ma'am, honorable judges, and my dear friends, myself Vidhubhushan Patra from class XI of section E from DIV Public School, UNIT-VIII, BHUBANESWAR. And in this today's physics seminar, our main topic is common forces in mechanics, and I have chosen the subtopic as tension force. So first of all, let us look at and examine this two pictures. That is, the first is world famous car festival, and the second one is a little child swinging on a swing. So let us examine and see, and we have come to a point that in both of these pictures there is one thing in common. both have two bodies having pulling forces is applied towards opposite directions. Here, if we take the mass of people as one body and the chariot as other body, there is a connective between them, that is rope, and pulling force is applied. And similarly, in the little child is sitting on the swing and exerting a force which is connected by a string, we can say. So let us come to the definition of tension force. So two or more physical objects that are in contact exert forces on each other by a string, rope, rod, or spring. We call the force as tension. Here in the figure, you can see two persons are holding a connection, that may be a rope or string, and their tension force is applied. So tension force is denoted by capital letter T, and it is a vector quantity. What is vector quantity? That has both magnitude and direction. And here this figure represents the physical representation of the tension force. Now comes to origin of tension force. So tension is when the springs are stressed. Here in the figure, there are two bodies or wires, we can say, and there is a connection. There is a connection that is it look like a rope, and tension is happened where these springs are stressed. There is a rope, and this rope is stressed. When the rope is stressed, tension is applied, and compression is when those springs are compressed. But our topic is about tension. The attachments and forces within and between these tiny springs are the electromagnetic forces, and thus we can say that tension is electromagnetic in nature. Now come to some important points. The first point is force of tension acts in the direction away from the point of contact or tied ends of this string. So in the figure, we can see a man is pulling a block towards him, and the force is given towards the opposite direction of the block, and the arrows represent the tension force. And also tension force is happens all over the string. Every part of the string, tension force is applied. Now the second point, string is massless and frictionless. Tension throughout the string remains constant as shown in the figure. In this figure, a pulley is there and two blocks are there present. If string is massless and frictionless, then the string string remains constant as shown in the figure tension. Now, if there is friction present but the string is massless, then the tension becomes different in the both of the cases. Now comes to the third point, that is, if a force is directly applied on a string, let's say a child is pulling a string from the other end with some force, the tension in the string will be equal to the applied force irrespective of the motion of the pulling agent. This we can reflect from the Newton's third law, that is every action has equal and opposite reaction. So above these 3 points are very useful in applications of Newton's laws to different situations. Now come to the tensions formula. Here in the figure, we can see how the system is made, and according to the Newton's second law, that is the rate of change in momentum is equal to the applied force. So for a block with mass m1, the equation we get is m1a equal to capital D, that is tension force, and for body m2, m2a equal to m2g minus t. So we get the acceleration, that is m2g whole divided by m1 plus m2. So by using the expression, we can get our tension force equation, that is T equal to m1 m2g whole divided by m1 plus m2. So unit of tension is Newton or capital N. And here a special case comes when the two blocks have equal masses, that is m1 equal to m2 equal to m, then the tension force equation becomes T equal to mg whole divided by 2. Now comes to some numericals, that is numerical number 1, lift parallel vertical loads using a pulley, that is here a pulley is shown and two iron blocks 10 kg and 5 kg mass, and simply we put the formula and get our answer, that is T equal to 65.33 Newton. Second one is use multiple strands to support a hanging object. Here we can see how 10 kg iron block is hanging with 3 knots by a string, and we can simply evaluate by taking angles and putting the formula T1 equal to 49 Newton and T2 equal to 85.26 Newton. And here's a note, this can also be solved by the Lami's theorem. Now come to the third numerical, that is a monkey problem. Here simply two monkeys are shown in the figure, and and the tension forces that are applied depending on the string and the tail of the monkey, we get the acceleration by putting the formula 5 meter per second square, and similarly max acceleration we get F equal to 105 Newton, and constant velocity or zero acceleration we get F equal to 70 Newton. Now come to some applications. That is, first one is car towing, we can see in the figure, and second one is pulling a bucket of water from well. Their tension force is applied. Now third one is tug of war. In sports competition we have often seen in the schools, and the here is the animated forms, and here comes the fourth point, that is crane machine, which is used to make high skyscrapers, etc., and tension in suspension bridge, that are hanging bridge, whose best example is the Howrah Bridge in Kolkata. So that was all for the presentation. Thank you for patiently hearing.
Thank you, Vidubhushan, for your wonderful presentation. Now I request the judges to ask their question.
Vibhu, nice presentation. At one point of time, you told that you uttered a word called vectors. Can you define once again what vectors are?
Sir, vectors are the quantities which have both magnitude and direction.
Okay.
It is the
current.
Yes, sir.
Current is having magnitude.
Sir, current. Sir, current is a scalar quantity.
Why it has got magnitude and direction?
Sir, actually, sir, direction is when the electrons pass from that is the negative electrons are arranged in the circuit, and the charge flows in that direction. But we can't say that current is vector quantity.
Achha. Then what about it doesn't satisfy? There is another condition also for vectors, that it should satisfy vector law of addition.
Yes, sir.
Okay. So since current satisfies Kirchhoff's law, so we don't have that to be a vector quantity. It's a scalar one. Okay. So three things are required for nominating it as a vector quantity: direction, magnitude, and vector law of addition. Ma'am, please.
Hello.
Yes, ma'am.
Vibhu, so many things you have explained within a very small time, right?
Yes, ma'am.
This much to explain this much, you need much more time. Within a very small time, you have explained a lot. Can you tell me the mechanism of Howrah Bridge? You have shown Howrah Bridge. What mechanism is there in the construction?
Yes, ma'am.
Explain.
The example I had given, that is Howrah Bridge, was the example of the suspension bridge. Now, I had told the definition of suspension bridge, that are those bridges which are made by hanging by using rod strings. Now, in that case, the strings which are let us take this as a bridge, and here the points from where the rod strings are attached to the bridge. Now the bridge is now in hanging state. Just take a portion of the bridge. Now this part is in hanging state. Now here the weight of the bridge is mg. We know the formula: mass of the portion into acceleration due to gravity. Here the force that is applied on the string, and the above there is from where the string is connected, between them the tension force is applied.
Okay. Okay, maybe more things are there. As per your convenience, you told. Okay, thank you.
Thank you, ma'am.
Thank you, Vidubhushan. Our next participant is Saswati Mishra of Standard 12C. Saswati, kindly respond.
Sati, you can share it. Saswati, you
Just
can.
a second, sir. Just a second.
Okay.
So I just got stuck, sir. Just a second.
Okay.
Sir, just a second, sir.
Soti, what is happening?
Sir, just a second, sir. Sir, I really apologize, sir. Sir, can I just show it at the last? Sir, I'm having some glitches, sir.
Okay, okay, okay,
I'm
okay.
so sorry. I apologize, sir.
Okay, okay. Don't worry, fine.
Okay, so we'll move on to our next participant. Our next participant is Ananya Dash of Standard 11E. Ananya, kindly respond.
Ananya, quick, okay, you say. Yes, you are audible, but your presentation also has to be visible.
Yes, sir. Yes, sir.
Okay.
Good afternoon, everyone, respected jury members, teachers, and my dear friends. I'm Ananya Dash of 11E here to present on the topic, the frictional force. So as we are quite familiar with the topic, the frictional force, and in our everyday life, starting from the morning till the end of the day, we are walking on the floor, we are riding vehicles, we are writing on notebooks and copies, and all these are because of friction. So here, just you can see one image where an object is placed on a surface, and here three types of force are acting. That is, one is the normal force, which is the upward perpendicular force, the frictional force, which is tangential to the motion, and the weight force or the force of gravity, which is acting as a downward force. So coming to the introduction, what is frictional force? Frictional force is a contact force which is resistive and it opposes the motion of the body sliding over a surface. Does it always oppose the motion of the object? No. For example, when a car is moving forward, the tires are pushing against the road in the backward direction, whereas car and the friction both are acting in the forward direction. Similarly, when a sprinter is running, the shoe is pushing backward, whereas the friction and the runner both are pushing forward. So they are in the same direction. What are the laws of friction? There are mainly two laws. One is that it acts in a direction opposite to the motion of the body. As you can see, a boy is pushing a cart, and here direction of motion is towards the left hand side, whereas force of friction is acting towards the right. And second is that friction acts tangentially to the motion of the body. Leonardo da Vinci, he discovered friction in a systematic manner in the 15th century, and he realized how important friction is for the working of machines. There are mainly two causes of friction. One is the classical view and another is the modern view that we are considering now. Classical view, according to this, due to interlocking of the irregularities of the two surfaces or two objects, friction is arising. And according to the modern view, we are considering the strong atomic or the molecular forces of attraction between the two objects. That is, here we can see that attraction between the molecules of the object and that of the surface as at a particular point, that is a point of contact. And as we know, pressure is inversely proportional to area. So if there is less area, there will be more friction and gradually more frictional force. There are two factors which are affecting friction, that is the materials which are in contact and the force that is pushing the two surfaces together. If the material is rough, there will be more friction, and it is smooth, there will be less friction. And another is the force that is pushing, that is, it is directly proportional. More is the force, more is the friction. Types of friction, there are mainly three kinds of friction: static friction, limiting friction, and kinetic friction. Again, kinetic friction is subdivided into sliding friction and rolling friction. Static friction arises between the bodies which are at rest. For example, a book which is kept on a table, or the table lamp resting on a table, creating heat by rubbing two hands together. These are some of the examples of static friction. Limiting friction, when static friction is maximum, we are considering as the limiting friction. For example, just motion, like we are starting a car and it is just motion. In that case, static friction is maximum. So that is the limiting friction. Sliding friction, when an object is sliding over the surface, the friction arises due to this motion is known as a sliding friction. Coming next is rolling friction. It is defined as the force which resists the motion of a ball or wheel and is the weakest type of friction among all the frictions. So examples are rolling of wheels of the bicycle or any vehicle, rolling of the log or rolling of balls in an inclined plane. These are some of the examples of the rolling friction. Here, static friction, sliding friction, and rolling friction have shown three images where in the static friction, there is no motion. Sliding friction, here the object is sliding and it possesses motion, rolling motion. In rolling friction, it possesses rolling motion. Coming next is the fluid friction. It arises between the layers of the fluid when they are moving relative to each other. For example, swimming in the water or a ship or a boat sailing in the water or the flow of ink in the paints. These are some of the examples of the fluid friction. So everything has applications. Similarly, mathematical application of frictional force is given by, I've given it by two questions. So the first question is that a mass of wooden pallet is given as 600 kg and the coefficient of friction is given as 0.28 and a lift driver decides to push it without lifting it. So here we are applying the concept of limiting friction. And by putting the values, we are getting value 1646 Newton. Similarly, in the second question, here the mass is 250 kg and mu is 0.05. Putting the values in the formula, we are getting it as 122.5 Newton. Applications in everyday life, between the tires of a car on the road, bottom of your sneakers on the ground, aeroplanes flying, and we are able to hold things, we're able to walk without sleeping, able to ride due to friction, drilling a nail, skating using skateboards, pressing and ironing your clothes, boating in river is possible due to fluid friction. Disadvantage, everything has a boon and a bane, so friction is a necessary evil. So disadvantages are we fall on a slippery or oily floor due to friction. It wears out steps of staircase in buildings and foot over bridges. Friction produces heat, that is unnecessary heat, which causes wear and tear of the moving parts of the machine. So thank you for your patient hearing. This ends my
Thank you,
presentation.
Ananya, for your wonderful presentation. Now I request the judges to ask their questions.
Ananya, you talked about fluid friction, right?
Yes, sir.
In one of your slides, you mentioned about fluid
Yes, sir.
friction.
Yes, sir.
So in particular, it has a name. What is that fluid friction called as?
So means other name of fluid friction.
Yes.
No, sir, I don't know.
Okay. Now, another thing you mentioned that the normal force will always be perpendicular, right? In the first diagram, where you have shown three
Upward
forces.
perpendicular force.
Yes, upward perpendicular force. It is always perpendicular to whom?
So means if an object is kept, it is like a perpendicular means to that object from upwardly.
No, perpendicular to the object what you are going to investigate is perpendicular to whom? Actually?
Sir,
Okay.
to the surfaces which are in contact.
In contact. Okay. Ma'am, please.
Okay, Ananya,
Yes, ma'am.
well presented.
Thank you, ma'am.
Can you tell me, you have mentioned many cases that coefficient of friction.
Yes, ma'am.
Okay, so what happens to the coefficient of friction when the weight of the body is doubled? If the weight of the body is doubled, what happens to coefficient of friction?
Ma'am, I don't know.
I don't know. Do you know what are the laws?
F is equal to normal force.
Do you know what are the laws of
Means it is
friction?
without. Yes, sir.
Do you know what are the laws of friction?
Yes, ma'am.
What are they?
Yes, ma'am. Ma'am, the laws of friction is one is that it acts in a direction opposite to the motion of the body. Another is it is tangential.
Tangential means what is tangential?
Ma'am, tangential to the motion of the body.
Okay, then
Frictional force.
two laws are there. Okay, thank you. Work on it, eh?
Thank you, Ananya. Our next participant is Priyanka Barik of Standard 11A. Priyanka, kindly respond.
Priyanka, are you there? You can. Priyanka. Priyanka. Please respond. Priyanka. Speak something. Hello? Yes. Yes, you are audible now. Priyanka, you are audible now. Yes. Okay, fine. PPT is visible, you can start. Yes, Priyanka.
Sir, am I visible?
Yes, yes, yes.
Good afternoon, everyone. I am Priyanka Priyadashini Barik of class 11A, roll number 28. Today I am going to present about gravitational force. I would like to start my presentation with what is gravitational force. Gravity, also called gravitational force in mechanics, is the force of mutual attraction between any two objects by virtue of their masses. It is by far known as the weakest force found in the nature. Its origin. The works of Isaac Newton and Albert Einstein dominate the development of gravitational theory. Newton's classical theory of gravitational force held sway from his Principia, published in 1687, until Einstein's work was published in early 20th century. When two bodies are placed at a certain distance, there is a force acting on object 1 due to object 2 and another force on object 2 due to object 1. Both of these forces are equal in magnitude and opposite in direction. Law of universal gravitation. Every object in the universe attracts every other object with a force directed along the lines of the center for both of the objects, that is directly proportional to the product of their masses and inversely proportional to the square of the separation between two objects. Here, to convert the directly proportional sign to equal to sign, we need a constant. So the expression we get is gravitational force is equal to gravitational constant into m1 into n2 all divided by r square. Here, g is a constant popularly called as gravitational constant. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Its value was found by Lord Henry Cavendish. Gravitational force among two spherical objects having uniform density is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Gravity on Earth. It refers to the gravitational force that the Earth imparts on the objects on or near its surface. In SI unit, it is measured in Newton. Acceleration due to gravity. When an object falls, the gravitational pull is 9.8 meter per second square. When a falling object is affected only by gravitational force, it is said to be in a free fall. I would like to evaluate the gravitational force with a numerical. Find the gravitational force between Jupiter and its natural satellite Callisto. The mass of the Jupiter is 1.99 into 10 to the power 27 kg and the mass of Callisto is 1.08 into 10 to the power 23 kg. The distance between Jupiter and Callisto is 1.88 into 10 to the power 9 meters. According to the question, the mass of Jupiter is 1.99 into 10 to the power 27 kg. Mass of Callisto is 1.08 into 10 to the power 23 kg, and the distance between them is 1.88 into 10 to the power 9 meter. To find the gravitational force between them, we have to apply the formula for gravitational force. So gravitational force is equal to gravitational constant into mass of Jupiter into mass of Callisto whole divided by the square of the distance between them. By substituting the values given in the question, we can get the answer, which is 4.39 into 10 to the power 44 Newton. The applications of gravitational force in daily lives are the force that holds the gases in the sun, the force that causes the ball thrown in the air to come down again, the force that keeps all the planets maintained in their orbit, the force from the sun and the moon that causes tides in the sea. Tides are the rise and fall of sea levels caused by the combined effect of gravitational forces exerted by the sun, the moon, and the rotation of the earth. The force that causes the moon to revolve around the earth. Gravitational force exerted by the earth on the moon provides the necessary centripetal force required for the moon to orbit around the earth. With this, I would like to conclude. Thank you and have a nice day ahead.
Thank you, Priyanka, for your wonderful presentation. Now I request the judges to ask their questions.
Priyanka,
yes,
difference in the value of capital G and small g.
Sir, can you repeat? I wasn't able to.
What is the difference in the values of small g and capital G? Can you tell those values?
Sir, the value of capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay. And the value of small g is 9.8 meter per second square.
Is it a constant or it can also change?
Sir, capital G is constant.
Small g? Okay, fine. Ma'am, please.
Okay, Priyanka.
Yes.
Okay, gravitational force, we have explained that it is the force between two objects. And the value you told is equal to G1 into the R square, right? So, let's say two masses are there and the force between them is 5 Newton. Yes, if those two masses I take inside water, then whether the force will increase or decrease?
Ma'am, if we put them in water.
Yes, those two masses I keep in water, the same distance, the same mass, and it will be there. But yeah, I'll place those two objects inside water. So the force between them, gravitational force between them, will increase or decrease?
It will remain same.
Yes?
Ma'am, it will remain same.
It will remain same. Why?
Because because it depends upon the mass of the both of the objects and the distance between them.
It depends on what factor?
The mass and the distance between mass of both of the objects and the distance between them.
Acha, gravitational force given by Earth on the sun is greater or the gravitational force given by sun on Earth is greater?
Can you please repeat the question? I wasn't able to hear.
Gravitational force given by sun on Earth is greater or gravitational force given by Earth on sun is greater? Which force is greater? Earth is attracting more or sun is attracting more? Whose gravitational force is greater?
Sun.
Sun. How?
Ma'am, because it has a mass which is greater than Earth.
What is the formula?
Gravitational force equal to gravitational constant into m1 into m2 whole divided by r.
And for the Earth?
And the formula for Earth it is same.
And then how the force is different? If the formula is same, then how the force is different? Okay, thank you.
Thank you.
Thank you, Priyanka. The last participant of the day is Saswati Mishra of Standard 12C. Saswati, kindly respond.
A very good afternoon to everyone, revered principal ma'am, knowledgeable teachers, and my dear friends. This is Sashwati Mishra from class 12C, going to start my presentation on common forces of mechanics, concentrating on the fact frictional force. I hope I'm visible and audible properly.
Yes.
Thank you, sir. The first thing which defines physics is a proper definition. So let's learn what friction is. Friction is a kind of an opposing force which always acts in the direction of the applied force. It opposes the relative motion between the two surfaces in contact. The next thing which comes to our mind is what's the origin of friction? When a microscopic body comes in contact with a macroscopic body, there occurs spaces which are very minute to our eyes. Thus, these irregularities are further known as friction. Friction is divided into three parts, that is sliding friction, fluid friction, and rolling friction. Sliding friction is further divided as limiting friction, kinetic friction, and static friction. Limiting friction comes into play when static friction reaches its maximum value and the body just starts moving. For example, we can consider a bike which is getting started immediately. Kinetic friction is a relative motion between two surfaces in contact. Fluid friction is the friction between the two layers of the viscous liquid that moves relative to each other is known as fluid friction. Static friction is otherwise known as the self-adjusting friction. It occurs up to which there is no relative motion between the two surfaces. Sliding friction occurs when a body tends to slide over another body. Further, when we add wheels to it, it gets converted to rolling friction. Physics is always incomplete without laws. So here are the laws of limiting friction. The first law is it depends on the nature of two bodies in contact. Second, it acts tangentially between the two surfaces in contact. Third, it is independent of the area of contact up to which n remains same. The fourth one is F is directly proportional to n, thus limiting friction getting directly proportional to the normal reaction. Limiting friction is always more than kinetic friction and both are dimensionless. Mu s is the coefficient of static friction, hence F is equal to mu s n and Kf is equal to Fk by n. We might have observed a wheel rolling on the ground. If we observe it minutely, then we will see that a very less amount of the wheel is in actual contact with the surface. Thus, here it shows that rolling friction is directly proportional to the normal reaction, but is inversely proportional to the radius. It's interesting to note that all the frictions are directly proportional to the normal reaction, except the rolling friction, which is inversely proportional to it. Here we come to the part of angle of friction and angle of repose. Let us consider an angle alpha, which is the angle of inclination. Then when the body just starts moving downward, the angle of friction becomes mg sine theta, and the normal reaction becomes mg cos theta. If we divide it, then we get tan alpha, which is equal to F by N, which is the coefficient of the frictional coefficient of friction. Here we come to the derivation of acceleration of a moving body down on an inclined plane. Here we can see that as the friction is less, that's why the body tends to slide down. Hence, after deriving the whole equation, we get that both the quantities
sine theta and mu cos theta are added with each other, hence making force is equal to mg whole into sine theta plus mu cos theta. Science is incomplete without applications. Here we can come across many of the applications where we can find pulling a lawn roller is always easy than pushing it, as mg gets subtracted in the first case, whereas it gets added in the second place. Thus making pulling easier than pushing. When we are walking, we usually tend to push the path behind us, which helps to walk, and we do not fall or we do not face any problem. Friction is a bane, a boon, and both the things. So advantages of friction, we can see that we are able to walk, we are able to ride. Machines work due to the belt and pulley system, which work under friction. So also there are some disadvantages when we purchase a new machine. When a lot of it gets exerted by it, we face a lot of problems in the efficiency problems. Thus, we can also overcome these problems by using ball bearings, polishing the surface, lubrication, and streamlining surfaces. Here we come to the last part of our presentation, that is a numerical, where we have considered a mass m moving down on the inclined plane with an acceleration of g by 4 and theta is equal to 30. Here the body tends to here mg sin theta is more than friction. Hence, F becomes mg by 4. So we come to the conclusion of mu k is equal to 1 by 2 root 3. I thank you from the bottom of my heart for the patient hearing, and apologize for the inconvenience caused earlier. Thank you, and have a immunified day ahead.
Thank you, Sashwati, for your wonderful presentation. Now I request the judges to ask their questions.
Sashwati, first of all, I want to congratulate for a nice way of presenting such a lucid thing, that is friction. Okay.
Thank you so much.
Fine. So I want to ask you one question. Rolling friction is smaller than your sliding friction. Is it true or false?
Yes, sir. Rolling friction is the only friction which is minimum than the other frictions present.
Can you just explain why?
Sir, because it has I'll try my best to explain this. Sir, rolling friction is the friction which is the only friction which is inversely proportional to the normal reaction. It has a very less contact with the second body which is in contact with it. So maybe that's why.
Minimum contact.
Yes, it has a minimum contact.
Ma'am, please.
Okay, Sashwati. Well presented.
Thank you, ma'am.
So can you tell me which type of friction is the weakest one?
I'm sorry, ma'am. Which type of friction is?
Which type of friction is the weakest one? Weakest.
I'm sorry, ma'am. I can't recall. I apologize.
Forgotten.
Ma'am, actually, I'm not getting it properly, ma'am.
Which type of friction is the weakest one? Whose value is less?
Oh, ma'am, rolling friction. It has a less value, I guess.
Yes. So that is the weakest one.
Yes.
Okay, thank you.
Thank you so much, ma'am. And I really apologize the whole team for the inconvenience I caused earlier. That was due to a glitch. Thank you. Thank you so much.
Thank you, Sashwati. The desire that guides me in all I do is the desire to harness the forces of nature to the service of mankind. I feel privileged to propose the vote of thanks speech and acknowledge the contribution of everyone who worked really hard to make this presentation a successful one. I, Shivangi, on the behalf of DAV Public School UNIT-VIII and the entire fraternity of the institution, first of all, extend my most sincere gratitude to the Almighty God for making today's event a resounding success. With His blessings and grace, we are able to make this event a joyful one. On the behalf of my school, I extend a really hearty vote of thanks to our judges who spared time from their busy schedule to grace the occasion. A special thanks to our principal ma'am, Mrs. Ipshita Das, and our supervisor ma'am, Mrs. Suryakanti Jema, for providing us this virtual platform, as on occasions like this, we get opportunities to test our knowledge and understanding. With deep sense of appreciation, I thank our physics department for the immaculate coordination of the event. And last but not the least, I thank our loving teachers and students for making this event a successful one. That's the end of our today's seminar. Thank you all and have a nice day.